All right, recording is rolling. It is Monday, May 20. Have an orienteering activity lined up for you guys, so I'll show you guys that in a minute. I'll show you guys how to read bearing. All right, so AP released your guys' FRQs that you guys just done on your exam over the weekend. So I do want to go over solutions with you guys, but I think tomorrow will be a good opportunity for that. Tell you what, though, too, is district comment. You guys remember here, this guy wrote his name on the board, Alan Sal. You guys remember I was recommended watch his videos to help study because he already covered solutions to them. I went down real fast, and it looks like he explained them exactly how I would explain them pretty much. So you got that. All right, so here's the exam schedule for the rest of the week. Of course, you guys don't have an exam in this class because you guys did AP exams. So, all right. And then, guys, be thinking about turning in your laptop sometime pretty soon. Think about if there are any files on your laptop maybe you want to get off. What's like the last day that you need to have it to be able to study for an exam, something like that. All right, so if you want to turn it in like today or tomorrow, I'd be able to check it in for you. We'll have a few experiments in class. But yeah, be ready to turn that at some point. All right, I do want to show you guys also more specifically schedule for next few days. All right, so the schedule at the top here is tomorrow, Tuesday. So guys, Tuesday schedule looks like each day is shortened a little bit, or each period, I meant to say, each period shortened a little bit. And then your 7th period is going to be a 2-hour block because that's when exams are going to be, 7th period. And then each day after that is just 2 classes. All right, so 6-5, 4-3, and then 2-1. All right, so they go, and those are like Friday length days. I think we get out 2:15. Yeah, get out 2:15. Looks like. All right, so there you go. All right, so you guys good with what's going on so far? All right, so switch back over here. All right, let's look at orienteering. I gave you guys each a treasure map. Treasure map. You gotta go outside and find Griffinbeard's treasure. I got a spade here. Got some buried treasure out there. We're gonna find it. All right, so all these start with the same first direction. There's a little bit different variations of this map, but they all lead to the exact same location. So there's one buried treasure out there. And so it says start at the west end field goal post. Draw guys the picture real fast. All right, let's say you guys know the practice field behind the school. All right, so here's like building 3, where we are. Go outside, walk down there. Right, here's field goal post. This is all behind the school. Right, you guys know practice field. Yeah. Right, and then we're going to say that this is the west end, so I'll label this W for west, and this field goal post is the east end, east. Right now, from that field goal post to that field goal post, it's almost exactly a west-east line, so we're going to say that it is west-east. Okay, great, west-east. You guys got that? Right. So that makes this north, and that makes this south. Right. So you guys got that? Right. 3D. Right. All right. Now, how do you read bearing? Because that's how I communicated all these directions here. Right. So I got 3 directions. You're going to start west end field goal post and then do what? Right? Now, really, all I did was I switched the order. It says walk so many meters at so many angle, right? So many degrees. Like, ooh, right? Now, guys, think about vectors. Vectors, some of the first things you guys learn about this class. If you do these in a different order, do they still lead to the exact same location? Yes, they do, because you can add vectors tip to tail in any order and you always get the same outcome, right? That's really what I did, just so that everybody's not in one giant ball necessarily, but you guys can kind of split up. There's 4 different variations on this map, and they all lead to the same location. Okay. Now, notice these all say so many degrees, like of north or of south. See how they're related to this north-south line? Okay. Now, that's just a convention that people came up with. Okay, but let's do it. We get a compass rose going. Okay. I think you guys would probably be able to figure this out anyway, but just for video completion, or if anybody wants to see this in a minute to chew this over. Okay. So this map says so many meters. And think about how to count meters, but students are pretty good at that, right? So I'm thinking a little bit more than 3 floor tiles. You could either take giant pirate steps or you could take shorter steps. I know my natural stride is about 70 centimeters, so I could maybe use that, right? Anyway, however you want to count meters. This one says I got 45 degrees east of north. Okay, it's 45 degrees east of north. So what does that mean? And so I'll start of north. So that's everything's related to this north-south line. That's bearing. Okay, then go 45 degrees east of that. And so protractor. Here's 0 up my north-south lines. Go 45 degrees. Bam. All right, that right there would be 45 degrees east of north. Right, you guys see that? 45 degrees east of north. All right. suppose that was so many meters supposed to walk. Right, now you pick up from that point and then go follow the next directions and so on. Right. Oh, I've got so many degrees. Oh, whoops, I wrote the wrong thing. Hold on. Whoops, that's not the map. I picked up a different map. Oops. Let's go back to this one. Right. I got 30 degrees east to south. 30 degrees east to south. Right. So I'll start relative to the of south and then go 30 degrees east of that. That's like down here. So just to get that. Oh, I'm starting from the origin just to show you this one vector in isolation. So there's like if I was starting with that step, there would be, bam, 30 degrees east to south. Right, you guys got that? All right. And then my last direction here says so many meters, 30 degrees west of south. Ooh, right. So again, just looking at this vector in isolation, right, and putting the tail at the origin again, right? 30 degrees west of south. So let's go of south, 30 degrees west, bam. That's like right there. Aha. And there is 30 degrees west of south. All right. Of course, if you had to be tip to tail, think of what this looked like, right? Say this one first, then slide this one, pop, tip to tail with that one, then bring this one, tip to tail with that. Maybe it lands you about here-ish, right? You guys can figure out, right? Oh, no. Okay, all right, so guys, one more detail, right? What are you looking for? Because there's buried treasure out there. Do you guys remember a few weeks ago, I had you guys do the lab with, you guys build a motor and electromagnet and all that deal, right? I give you guys these big old bolts, right? They look like this. Right, you guys remember those? Right, you guys remember? Right, they're about maybe about as big as the pin, right? Right, and the head of this bolt is about the size of a dime. In fact, it looks kind of like a dime, right? That's what it looks like from above because I hammered one of those in. All right, you guys ready to go find some treasure?